Hi everyone, it's Miss Berry. In this video today, we're going to be going over section 10.3, which is called Hypothesis Testing for the Population Mean when Sigma is Unknown. All right, so we're just combining the stuff that we learned about hypothesis testing with the stuff that we know about the student's t-distribution. All right, so I'm going to mute my camera, share my screen, and we'll get started. All right, there we go. All right, so hypothesis testing for a population mean when sigma is unknown. All right, so once again, just to remind you, sigma is the population standard deviation. Population standard, go back. Standard deviation. All right. Just to quickly review, the 4 steps for conducting a hypothesis test. I don't know why that showed up on this screen, and now, of course, it won't go away. All right, we'll just ignore that. Okay, just reviewing the 4 steps for conducting a hypothesis test. We begin by stating the null and alternative hypotheses. Null hypothesis is HO, that's the value that's currently believed to be true. It always contains an equal sign. Alternative hypothesis, that's going to be HA, that's the claim that we would like to prove. And it always contains an inequality, so greater than, less than, or not equal to. All right, then we figure out what type of test are we supposed to use here based on the information that's given, and we state the level of significance alpha, which is always going to be given to us in the problem. Step 3, gather the data, calculate our necessary sample statistics. From here, we'll just grab the values, and then our last step is to draw a conclusion and interpret the decision. Remember, the way we draw our conclusion, we compare the p-value to the alpha, to the stated alpha level. So that's why you want to make sure and state the alpha level at the beginning, so that you don't choose your alpha level based on what your p-value is. All right, and so you draw the conclusion. If p is low, reject HO. Then we use our little template sentence to interpret the decision. All right, so here's our first example. A children's clothing company sells hand-smocked dresses for girls. The length of one particular size of dress is designed to be 24 inches. The company regularly tests the lengths of the garments to ensure quality control, and if the mean length is found to be significantly longer or shorter than 24 inches, the machines must be adjusted. The most recent simple random sample of 18 dresses had a mean length of 21.65 inches, much shorter than intended, with a standard deviation of 4.70 inches. Assume that the population distribution is approximately normal. Perform a hypothesis test on the accuracy of the machines at the 0.025 level of significance. All right, so just pointing out the important stuff here. The length is designed to be 24 inches. So that's the value that's believed to be true. All right, and we're looking at the mean here. So I know this is a hypothesis test for a mean. Whenever we are looking at our alternative hypothesis, they said that if it's longer or shorter, then we need to adjust the machine. So we're looking for less than 24 or greater than 24. So we're going to do not equal to for our alternative hypothesis. And our sample size here was 18. And we had a sample mean of 21.65, sample standard deviation of 4.70. And then it gave us our level of significance. All right, so a couple things that I noticed here. There was no mention of the population standard deviation. I did not see the phrase population standard deviation anywhere in this problem. So that means sigma is unknown. Okay, if sigma is unknown, we cannot do a z-test. One of the assumptions of the z-test is that sigma is known. So if we don't meet the criteria for a z-test, then we have to do what's called a t-test. Right now, you're going to get there with the same steps. We're going to go to stat, go over to test, and then I believe it'll be option 2, but we'll see in just a minute. Right, but you're going to select t-test. That's supposed to be an arrow. Okay. All right, so let's write down our important information before we jump over to our calculator. We need to state our HO and our HA, our null and alternative hypotheses. We need to state sigma. Nope, sorry, that was alpha. We need to state our alpha level. We need to know our sample mean, our sample standard deviation, and our sample size. All right. We said this was a hypothesis test for a mean, so go ahead and put mu, the symbol for population mean, in our null and alternative hypotheses. The null hypothesis always gets the equal to. The value that's believed to be true is 24 inches. And we're going to have to adjust the machine if it's longer or shorter. So we're just saying our alternative hypothesis is that it's not equal to 24 inches. Our level of significance, kind of a weird level of significance, 0.025. Right, so that was given to us right here. Our X bar, our sample mean was 21.65. Our sample standard deviation was 4.70. And our sample size, if y'all remember, it was 18 dresses. All right, so let's grab our calculator. All right, here we go. All right, so we're going to go to stat, then go over here to test. Yep, and it is option number 2, t-test. You're going to see the same two options up there at the top, data and stats. Data, that's if you had to type in, if you had to manually type in the data into L1. We did not have to do that, so we're just going to make sure stats is highlighted. Then we're going to go through and fill out our information. Our assumed value, our null hypothesis was 24. Our X bar, our sample mean was 21.65. Our sample standard deviation S was 4.70. Sample size was 18. I know y'all are impressed that I remembered all that. Remember, our alternative hypothesis was not equal to. Then we go down to calculate. Remember, we said that the draw option, that's if you're doing the rejection region method. Calculate is if you're doing the p-value method. All right, so hit enter. And there's our numbers. Now, I did want to tell you, on a lot of the problems on the homework, they will ask you for the critical value. That's what T is. So T is giving you your test statistic. Maybe that's what they call it. So they're going to ask you for a test statistic, and that's here, negative 2.12. And then there's our p-value. If we round to 2 decimal places, that would be 0.05. 0.05. All right, so let's get back over to the right place. All right, P was 0.05. So now we can worry about making our decision. And we're going to ask ourselves or remind ourselves of the phrase, if P is low, reject HO. All right, so you're asking yourself the question is, not if, is, I was doing so good. Is P less than alpha? All right, so here's P, 0.05. Alpha is 0.025. So again, we said if you're struggling with comparing those, think of them as percentages. That would be 5%. This would be 2.5%. So yeah, definitely not. It is not less than alpha. So if your p-value is not less than alpha, then we have to fail to reject HO. And I think the template sentence that I was using was something like, we do not have sufficient evidence. I noticed on the homework that they say insufficient, so we'll use that here. They say something like, there is insufficient evidence to, and we'll better put the significance level. We'll say there is insufficient evidence at the 0.025 level of significance. I'm trying to write neat. To suggest that, and then you just restate the alternative hypothesis, which is that the average, we'll say average length. That's how they describe it in the problem, the mean length. Right, so the average length is not 24 inches. So even though that sample mean was super low, that's a lot shorter, right? If you're thinking about the length of a dress, that's almost 3 inches shorter than what they intended. So even though we had that super low mean, I think what came into play here was the very low significance level. This is a pretty low level of significance. Just think if we had done 0.10, we would have rejected HO. And then we also had a pretty large standard deviation, 4.7 inches. That's pretty, that's a pretty large standard deviation if you think about it in terms of the length of a dress. All right, let's look at another one. A pizza delivery chain advertises that it will deliver your pizza in 20 minutes from when the order is placed. Being a skeptic, you decide to test and see if the mean delivery time is actually more than 20 minutes. All right, we got a bunch of information right there. For a simple random sample of 8 customers who record the amount of time it takes for each of their pizzas to be delivered, the sample mean is 22.2 minutes, and the sample standard deviation is 3.1 minutes. Okay. Assume that the population distribution is approximately normal. Perform a hypothesis test using the 0.10 level of significance. All right, much higher level of significance on this one. All right, so let's write down all the stuff. HO, HA, alpha, X bar, S, and sample size. All right, so null hypothesis, alternative hypothesis, level of significance, sample mean, sample standard deviation, and sample size. All right, so let's start writing stuff down. All right, so we saw the word mean in here, so we're going to go ahead and use mu. We know that the null hypothesis always gets the equal to. The value that's currently believed to be true is 20 minutes. We believe that it takes 20, or the pizza chain advertises that it takes 20 minutes to deliver the pizza. You think that it actually takes more than or greater than 20 minutes. You've decided to use the 0.10 level of significance. All right, if you recall the interpretation of the level of significance, that's like the probability of making a type 1 error. Right, so that's the probability of making a mistake. So you're saying, okay, I'm okay with making a mistake about 10% of the time. Right, and then X bar is 22.2, they said. 22.2. And then standard deviation was 3.1. Sample size, very small sample, just 8 customers. All right, so I didn't mention this before, but if they have a small sample size and they're going to call that, like they're going to distinguish a small sample as being less than 30. So if you see a sample that's less than 30, then they have to tell you that the population distribution is approximately normal. Otherwise, you wouldn't be able to use the t-distribution. So that's one of the criteria for the student's t-distribution, is that the population is approximately normal if you have a small sample size. If you have 30 or more for your sample size, you don't have to know that. Okay, let's grab our calculator. Y'all think I can remember the numbers this time? Not get too cocky, right? Okay, stat, test, t-test. All right, stats, 20 minutes they say it takes for a pizza to be delivered. Average sample mean was 22.2. Sample standard deviation, nope, I've already forgotten it. 3.1. Sample size was 8, and we said that we think it actually takes more than 20 minutes. So we're doing greater than the null hypothesis. All right, so then go down to calculate and hit enter. There's our test statistic, 2.01. P-value is 0.04. 0.04 for our p-value. Okay, let's interpret or make our decision and then interpret. All right, so remember, if P is low, reject HO. So is P less than alpha? Yes. P is 0.04, alpha is 0.10. That's like 4%. That's like 10%. So yes. All right, so we get to reject HO. All right, let's write our interpretation. Last time we said there is insufficient evidence. So this time we'll say there is sufficient evidence. There is sufficient evidence at the 0.10 level of significance to suggest or to conclude that, and then we're going to restate the alternative hypothesis, which is that the mean delivery time, that's how they described it, the mean delivery time is more than 20 minutes. Is more than 20 minutes. All right. Cool. All right, let's look at another one. Oh, this is our last one. It currently takes users a mean of 13 minutes to install the Respondus Lockdown browser software. After changes have been made to the program, the company executives want to know if the new mean is now different from 13 minutes so that they can change their advertising accordingly. A simple random sample of 71 new customers are asked to time how long it takes for them to install the software. The sample mean is 12.1 minutes with a standard deviation of 2.9 minutes. Perform a hypothesis test at the 0.05 level to see if the mean installation time has changed. All right, so I'm just going to highlight some important stuff, and then I'm going to ask you to try this one on your own. So this is the value that's currently believed to be true, that it takes 13 minutes to download the software. They want to know if the new mean is different than 13 minutes. So does it take less than 13 minutes? Does it take more than 13 minutes? Their sample size is 71. Sample mean is 12.1. And then sample standard deviation is 2.9. And again, I'm not seeing the words population standard deviation, so I know that I'm going to have to do a t-test. And then I see that the 0.05 level is my, that 0.05 is my level of significance. All right, so I want you to pause the video, try this one on your own, and then just check and see if you get the right answer. I'm just going to work quietly. Okay. Is P less than alpha? Yes. 0.01 is less than 0.05. So we're going to reject HO. All right. Let's write our sentence. There is sufficient evidence at the 0.05 level of significance to suggest that the mean installation time, right, so yep, that was how they described it, mean installation time, that the mean installation time is not 13 minutes. All right, let me switch back over to my camera. Hi. Thank you guys for watching this video. If you have any questions, please let me know, and I'll see you guys in the next one.